Welcome to the next installment of the lessons on the selection sort. In today's lesson, we're going to look at the metrics involved in the selection sort. The metrics refer to the efficiency of this sorting algorithm. Before we get started, we're going to need to get some files, so we're going to visit the website for this class. You can get there by going to mchs-cs.com and click on Period 2 AP Computer Science A Java Programming. From there, click on the Video Tutorials link and choose a lesson. Today we're going to be doing SelectionSortMetrics. If we scroll down a bit, we can see some links associated with this lesson. The first is a worksheet. This is the worksheet that you'll be filling out as you finish this lesson. You are welcome to download the PDF, print it out, and fill it out using pencil and paper, or if you prefer, you could download the Microsoft Word document file and use that instead. And of course, the next thing we're going to need is our SelectionSortMetrics project that we're going to import into Eclipse. So, after we've downloaded that, we'll switch back to Eclipse and we're going to import our new project. So I'm going to go to File and choose Import. I'm going to select Existing Projects into Workspace and then click the Next button. Make sure that you have Select Archive File checked and click Browse. Navigate to your Downloads directory, select the SelectionSortMetrics project and click Open. And you're ready to click the Finish button to finish the import. Now, in the Project Explorer, I can open that and I can see my usual source file or folder, a JRE system library, but there's also a new file here called arraytoolkitlib.jar. What is a jar file? Well, a jar file is compiled Java code that you can use in your program. And this jar file is going to make it so that our code is a little bit shorter and easier to read. So let's begin by opening the src folder, open our default package, double click on SelectionSort.java. The code should look very familiar because it is basically the code we finished up with last time with just a couple minor modifications. I'm now going to minimize the Project Explorer and I am ready to begin. Okay, so the first thing I'm going to do is see how to use the array toolkit lib. So here in our code, lines 17, 18, and 19, swap two array values within our array. I can shorten this code by using the arrays toolkit lib. It's array toolkit lib.lib and find the swap array values method. Now, for this method, all I need to do is tell it what array I want to swap, which will be ARR, the index of the first value in the array, which will be my min index, and then the value of the second array index, which will be my swap index. That one line of code replaces these three lines. And that takes care of that. Now, the next thing that I can use the array toolkit lib for is to take the place of this print method here. So I'm going to delete the print method because then Eclipse will helpfully point out everywhere where I was using it. And so I can see that I have to do something about this line right here. So I'm going to delete print and change it to array toolkit lib dot list array values. And I want to make sure that I check the one that says list array values. Actually, I don't want it, yes, the one that says string label. Now, here it already has my values filled in, but I already have them from my print method, so I'm just going to delete them. And I want that exact same line right down here, so I'm going to erase it and replace it with that. Okay, now I'm ready to begin thinking about the metrics of my algorithm. When we talk about sorting method or algorithms, we generally want to know how many times the algorithm has to compare two values in order to complete its process. So I look in my code for the place in the algorithm that compares my array elements, and it's right here. So what I can do is say that anytime I'm about to do a compare, I'm going to want to keep track of that. So I'm going to create a new variable up here, right before my code begins, it's an int called compares, and set it equal to 0. Then, just before my if statement here, where I do a compare, I'm going to say compares plus plus. Then, after my algorithm has run its course and I display the results here, I'm going to add a couple more lines. The first thing that's going to be useful is to know how many elements there were in my array total. So I'm going to say total elements equals plus arr.length. Next, I'm going to output the number of compares. So I'm going to write another print line statement. Okay, now I am ready to see how many compares it takes to complete an algorithm with 5 elements in it. And there I can see that my array had 5 total elements, and it had to perform 10 compares before it was done. The next piece of information that's often considered when we're talking about the efficiency of an algorithm is how many times the algorithm is required to swap two values. So I'm going to add another variable up here called swaps and set it to 0. So where in my code do I do a swap? Well, right here. So I'm going to say swaps plus plus there, and then add another system out print line to tell me how many swaps were done during the course of this algorithm. And now I can run it. Now, when one is analyzing an algorithm for efficiency, what you generally want to know is what happens to the number of compares and the number of swaps as the number of elements increases. So we're going to change our array here to have 10 elements and run it again. And this time we can see that it required 45 compares and 10 swaps. And now we're ready to start filling out our worksheet. So I'm going to go back to my downloads directory and open my sorting analysis worksheet document. And then right here at the top, under data sorted in reverse order, usually the worst case scenario, because our data started out in reverse order, it took how many swaps, or how many compares? 45. And it did 10 swaps. Next, I'm going to go back to my program here, and if I look at my chart, I can see that the next number I need to do is 20 elements. So I'm going to change this to 20, run it again, and I can see that now I have 190 compares and 20 swaps. So I'll fill in 190 here and 20 here. And then I'm going to run it again with 30. I get 435 and 30. And finally, or not finally, next I run it with 40 elements. And wow, I'm up to 780. You math majors might be starting to see a relationship between the number of elements and the number of compares. Now I increase it to 50 elements, and my numbers start to get really large. It took 50 swaps and 1,225 compares. So, at this point, I'm going to stop, and I'm going to graph these results and see what kind of a curve I get. So, It's going to be 40, 190, 435, 780, and 1225. If I go down to my second page here, I can see that I have a graph set up for my selection sort. If I click in the graph area, I can edit the data. Of course, you can do this with pen and paper. For 10, we had 45 swaps. For 20, let's scroll back up, we had 190. Then for 30, we had 435. For 40, we had 780 and 1225. Now, thanks to the magic of Word and Excel, if I go back in here, I can see, oops, apparently I didn't hit return there, that my graph is conveniently filled in for me. And if I look at the shape of this curve, it closely resembles the curve for x squared. And that describes the efficiency of this particular sorting algorithm. As the n, the number of elements, increases, the number of compares increases at a quadratic rate. Now, the function is somewhat more complex than just x squared, but it is considered to have an efficiency of n squared, which is to say its big O, or its efficiency, is that of n squared. As n increases, the number of compares increases at roughly an exponential rate. Now, to complete the worksheet, there are two other cases that we have to consider. What happens if our data is already sorted in optimal order? In other words, if our data starts out sorted in correct order. Well, if I go into my code here and change it so A of I gets the value of I, that means that the first element will have the lowest value, and I'll lower this back down to 10 and run my program. So, my data started out in order 0, 1, 2, all the way up to 9, and ended up in order. And yet I still had 45 compares and 10 swaps. So even though it wasn't actually necessary to change anything, this algorithm still compared 45 times and swapped the values 10 times. Not very efficient. So, the next thing you're going to do is run that same algorithm for all these other values to fill out the rest of the chart. You don't need to graph the optimal order to see what happens. You just need to look at it. And then we're going to look at a third case, the random order. So how do we put random data into our array? Well, once again, our array toolkit lib is going to help us because it has a random number method which allows us to set the minimum value and the maximum value. I'm going to set the maximum value equal to the length of the array. And now, when I run my program, I can see that I have random values in my array here. Oops. 10, 6, 1, 7, blah, blah, blah. And then at the bottom, I have my numbers in numerical order. And I can see that it again took 45 compares and 10 swaps. So, we're going to go back to our chart and fill those numbers in. 45 compares and 10 swaps. And you will complete the worksheet by filling out these values for these other numbers of elements. Next, you're going to try to fill out the sorting algorithm summary. So, for the selection sort, what is the general efficiency, or the big O? In the best case, how many comparisons are performed? Now, the math on this is a little bit more complex than you might think, because each time it goes through the for loop, it does one less comparison on the inner for loop. So the math equation equation for the number of compares for the best case, even though we generally refer to it as an n squared, is not in fact an n squared equation. For those of you who really want to earn some extra points, do some research and see if you can figure out what the actual equation is. And you are done. You'll be done with all the information you need about the selection sort. In the next lesson, what we'll do is we will look at ways to make the selection sort more efficient. How can we make it so it doesn't waste so much time doing unnecessary work? Hope to see you in the next lesson.